Let's have a look at one example of volume of composite solids. And this example seems to come up every so often, and I have actually seen this question or a very similar one. Anyway, we have a situation where a sphere or a ball is placed inside a box, and it's a perfect fit basically, so the sphere touches the sides of the box, and it's a cube. So in this case, a sphere of radius 5 centimeters is placed in a cube-shaped box such that the sphere just touches the sides. Okay, so think of a tennis ball sort of fitting perfectly inside a cube. Calculate the percentage of volume wasted. So clearly, sorry, it's probably not the best attempt at drawing a sphere, but you could imagine that there's going to be some wasted volume. Okay. So there's two things that we're going to need. We're going to need obviously the volume of the cube. We're going to need the volume of the sphere, and obviously the percentage is going to be the volume of the sphere over the volume of the box. So we need to start thinking about a strategy here. Okay, so and we want the percentage wasted, not the percentage taken up as well. So just be mindful of that too. So this might look like an easy question. It is an easy question. But there's a couple of pitfalls we've just got to be careful about. And as long as we're careful about that, the question's fairly easy and quite easy to tackle. All right. First things first, let's work out the dimensions of the box. We're told that the sphere is radius 5 centimeters. So that means from here to the edge, okay, that's 5 centimeters. So what would the dimensions of the box be? Okay, so the dimensions of the box, okay, is going to be, so if that's 5, it's going to be 10 by 10 by 10, okay, right, 10 times 10 times 10, and it's all in centimeters, okay, so that's going to be 1,000 cubic centimeters, okay, exactly 1 litre, 1,000 milliliters, but we're not dealing with litres and milliliters. We'll just keep it in cubic centimeters. Okay, what about the volume of the sphere? Okay, I'll say that volume is equal to 1,000 cubic centimeters. Okay, so volume of the sphere, okay, is 4 pi r cubed on 3. Okay, so V is equal to 4 pi times, now R is 5, cubed over 3, and I might round this to 2 decimal places, so just keep the rounding just reasonable rounding, so 5 cubed, I might just put it here so you can see what I'm doing, so 4 pi times 5 cubed over 3, and we get 523, and I'm going to use a little bit more than just 2 decimal places. I think I'm going to use 4, and then we'll round it back down to 2 at the end. We've got to be very careful when you're rounding inside a calculation, okay? Do not round too aggressively or at all, even inside a calculation if possible, okay? But if you find that a little bit too difficult to work with, what I would suggest, either just write the entire calculator answer, okay? And so this entire answer, just write that down and then round it right at the very end. And I think that's probably the best policy. So why don't we apply that, and we'll do that. Might sound like a bit of a pain, but you're not going to have rounding errors, okay, at the end. You're not going to run that risk. So 598, 7756. It's easy enough to write. And that's, again, cubic centimeters, okay? So what about the volume wasted, okay? So volume wasted is clearly the volume of the box minus the volume of the sphere or the ball. So that's going to equal 1,000 minus 523.5987756. Show you're working out. All right? Even if you get the answer wrong, there's a good chance that, or a reasonable chance at least, that you may still get some marks for your working out if your working out is logically sound and sufficient enough. So that's going to be 1,000 minus my previous answer, which is 476.40122244. So the percentage, okay, of volume wasted is going to be this value here divided by 1,000. Okay, so percentage of volume wasted, hopefully I can fit that in, is 476.4012244. Divide that by 1,000, and I'll just do that now on the calculator. I'm just about running out of space. And of course we multiply that by 100 to convert it into a percentage, and we get 47.64%. Okay, do it in a different color so you can see my answer. Sorry about that, I had to squash in a little bit. Okay, 47.64%. That's quite a lot. Okay, so clearly it's quite inefficient then to package reasonably inefficient to package a sphere inside a box. But then how are we going to put it on a shelf if you wanted to display it? Okay, so these are some of the challenges that sometimes when we're packing things for storage or for transport or for display purposes, we need to be conscious of how much space is in fact wasted. Okay, so in the next example, we'll have a look at an example of surface area with composite solids.